phone went off while I was half asleep, and then I heard it, and I was like,
Okay, so good morning. Happy Monday. We've taken lecture 22 and we've broken it into 3 parts. Part A, we talked about the exponential function. Part B was on Thursday, Friday, where we did applications. Remember we did A equals PERT, and we did A equals P. We did compound interest formulas on Thursday, Friday, remember that? Yes?
Yes. Wait, what's the first one?
Up here? Exponential function, and then we did some applications.
okay, so this is.
Yeah, what's the first application?
Continuous compounding. A equals PERT. Principal, natural log. Alright, so today we're going to do part C. It'll be the last one. Now, I don't know we'll get through all of it. We'll get as far as we can. There's quite a bit to add in today, so what we don't get to we'll finish tomorrow. But we're going to look at the log function. And then when this is done, we are done with this lecture 22. We're ready for our next exam. So we'll take, I think, will this be our first exam or our second? First. Our first exam, okay. So we'll do our first exam and then and get you ready for that. That'll be next week. Okay, I haven't decided what day. It obviously will not be on.
For Tuesday.
Maybe Thursday.
Yeah, I gotta look at the calendar because I think we have a day next week.
Why not Tuesday?
Why can we do it Tuesday?
What's on Tuesday?
Why would I want to take a test? Because okay, if I take the test, right, you can know if you did good on the test.
Oh, so
or
there's
bad,
no events going
right?
on. I thought.
So that means like I will
Yeah,
have
we
to
have
be
a full week next week, right?
heartbreak for the rest
So
of the week.
it could be a Tuesday. It could be Tuesday, Wednesday, probably would be my guess.
Yeah, I read the book and cried.
All right, here we go. So we're gonna look at the log function. So I've been shortening it log this whole time. It actually stands for logarithm. Okay, and here's the reason I want to approach. First of all, why do we need logarithms? Okay. So let me give you an example. Let's say you're given, you want to reach a goal of $10,000. You want to have $10,000 in your account. You currently have somewhere around 5,000. And you're going to put it into, I don't know, maybe a money market account or a certificate of deposit. That's going to give you 5% compounded quarterly. And then you want to find out, okay, how long will it take for that money to double? Okay, so I have 5,000, my goal is 10,000. How long will it take me to get to $10,000? Okay. Did you say what?
Isn't this the other thing? I thought logs was like with the bottom.
Okay, so stay with me. So if I solve this a little bit, divide both by 10,000, 2 equals 1 plus, does someone have a calculator? What is 0.05 divided by 4? Okay, it doesn't really matter. The point is though, where is my unknown? My unknown is in the exponent. Well, okay, so how do I solve for t? How do I get t out of the exponent so that I can eventually come down here and say t equals some value? Because I have the exponential, but it's unknown. So I want to come down and figure out what does t equal. The only way to get the unknown out of the exponent is to use logarithms. To take the logarithm of both sides will allow me to bring this t out of the exponent, this unknown out of the exponent, and bring it down into a number where I can actually solve for it. Okay. So that's the reason we do logarithms, is to solve exponential equations. So in other words, let's say if I have f of x equals b to the x, and I say solve for x. And maybe you're used to saying y equals b to the x. Well, how do you solve for x? How do you solve for that value? How do you get that out? And that's what we're going to use logarithms for. Okay. Some of you may have seen this first part. We're going to convert, but then we'll look at some log properties and we'll see. All right, so here's the definition. For x greater than 0, and b greater than 0, b not equal to, once again, what can b not be equal to? 1. B greater than or equal to 0, b not equal to 1. Then I'm going to write it backwards if that's okay. Then b to the x power equals y is equivalent to, and here's where your logarithm comes in, okay? Is equivalent to log to the base b of y equals x. How many of you were in this Corvinus class? For Algebra 1, Geometry, Algebra 2? So she probably taught you the swoop. Do you remember the swoop? Sounds familiar? Okay. So what is this here? Why is this here? Okay. It's Monday. Okay, so Miss Cravina taught me the swoop several years ago. She said, if you have this exponential function b to the x equals y, then simply start at the base, okay, and swoop around. So then when I convert it, you start off with log, and where did I start? B, so that's my base. What's the next thing I come to? Y. Equals, what's the next thing I come to?
X.
X. Have you seen that before?
Yes.
It also works backwards. Okay. If you start with your base B and you swoop, you go B, the next thing you come to is the X, the last thing you come to is equal to Y. And you can swoop back and forth. And that's converting from an exponential form, notice where X is in the exponent, to logarithmic form where there are no longer any exponents. Everything is out of the exponent. It's brought back down to normal, if you will. All right, so let's do an example of how this works. And you might want calculators eventually when we do this. So let's say we have 7 to the power of a equals 3. Now think about what that's asking. Okay, 7 to the power of a equals 3. 7 to what power? So if I do 7 to the 0 power, what is 7 to the 0 power? 1. What is 7 to the first power? 7. Well, I want it to be 3. So 7 to what power is going to be 3? It's going to be somewhere between 0 and 1, some sort of fraction, decimal, maybe an irrational number. Okay? And it's very, very difficult to find what that's an A, by the way. Did you guys think it was a 9?
Yes.
Okay, good.
I thought it
I was expecting someone to say after I looked at
What
it.
are those bottom ones?
Say it again.
It goes 7 to the power of 0, 7 to what?
The first? Okay, so here's my thought process, thinking it through. 7 to the 0 power equals 1. 7 to the first power equals 7. I'm looking for some number that will make it equal a value of 3. So A has to be greater than 0, but it has to be less than, it has to be somewhere between 0 and 1. So let's convert it. Log to what base? 7 of, and for lack of a better term, I just call this number here the argument. I don't really know what that term would be for that, so I always call it the argument. Log to the base 7 of 3 would equal A. And if you take your calculator out, you can put that into a calculator, will give you a decimal. Not all calculators will change the base, so. So nice of you to grab extra. This is why you're Yellow Jacket of the Week.
Okay.
Did I nominate you for the Yellow Jacket of the Week? Did I nominate her?
She know.
Did you nominate her?
Yeah.
I nominated like 4 people.
Oh.
She's not making it.
Say it again.
She's not making it.
I thought I did already.
Yeah, you did.
She
So you
said
do
she
it
wanted to
again.
go too.
Well, why did you do it once?
Huh?
Okay, so what is log to the base 7 of 3? Should be some sort of fraction between 0 and 1.
Point 5, 6,
Point.
5, 6, 4, 5, 7, 5, 0, 3, 4.
Okay. Okay. Did y'all hear what he said?
A lot of numbers.
Because listen, this is important. Did you hear what he said?
Yeah, yeah.
Okay. 3 places, don't round.
5, 6,
0.563.
4.
4. 3 places, you don't have to round. It's called truncating. We're just going to cut it off. Go 3 decimal places and stop.
You even put the little squiggly thing to say it keeps going?
Say it again.
You even put the little squiggly thing to say it keeps going?
Yeah, we can. I'm not too concerned about that notation, but yeah, you could actually do that because it's approximately 0.564. Good point. So, ladies and gentlemen, one use of logarithms is if I don't know what that a is. If I don't know the value of that, I can switch into logarithmic form and it will tell me what the exponent will be. Okay, we good with that? Here we go, another example. What if I did it backwards? What if I gave you log to the base 6 of some value x equals 3? Okay, so swoop it. Let's go ahead and convert this. So the base would be what? 6, you start with the 6. To what power?
3.
3 equals x. So then you just do 6 to the 3rd. And we can do that without, okay, half letter is 260. All right, what time are we out here? 10:30, good. So I've got 5 properties. Now, the cool thing with logarithms, they have these very cool properties that allow us to solve log problems. Okay? So we're gonna go through the 5 properties. Some of them you've probably seen, some of them maybe not. Number 1. These are log properties for those of you taking notes. Okay, so the first one, sorry, I don't have my notes. Log to the base b of b equals. Anyone have a guess?
Like what it equals to?
Say it again.
I guess of what? What property is it?
I am deaf. Can you say it one more
What
time?
are we guessing? Like
What the answer is?
it
What's
goes
log to the base b of b?
I wanna say
X.
B.
You want to say b? You
Yeah.
want to say x?
Are we writing it out?
Y. Would it be like?
What'd you say? A. Okay. Class. Let's do this real quick. Let's just plug in a letter. Okay? Let's plug in, I heard someone say Y. Let's plug in Y. All right, now, I'm gonna come back and put a number in here in just a minute, but let's go ahead and swoop it, okay? B to the power of y equals B. What's y going to be?
5.
I'm sorry? Did you say 0?
No. It's gonna be 1.
Thank you. And whenever these two numbers are the same, it's called the identity rule. When the two b's are the same, the answer is always going to be 1. So if I give you log base 10 of 10, which would equal log base 7 of 7, log base pi of pi, you get the idea they all equal 1. Law of property, what's called the identity rule. Number 2.
Hey,
whoa. What? Why are you looking at me?
Because you said, well,
That was not, that was Bonnie. That was me. You think we sound the same?
Yeah.
son, you know I'm half deaf, right?
Wait,
No,
what's
I think you just have selective hearing.
I don't have selective hearing. If I'm not looking at you, my ear's clogged, I don't know where it's coming from. I have a difficulty hearing, so people just need to speak up. It'll be cleared up once, it'll be cleared up here once the weather settles down, once we get out of this human stuff. Are you good? Okay, number 2.
I hate December.
it's fall.
That's what they keep saying. Fall with these 90-degree
Log.
days.
It's gonna be like 30 on Friday.
To the base b, and this time the argument is 1. Okay? What's it gonna be equal to? Swoop it and figure it out. I'm sorry? 0. Okay? This is called the 0 property, or the 0 rule. Because b to the 0 power equals 1. Whenever this right here, whenever the argument is 1, the answer is just going to be
Still low.
0.
Yikes.
That's nice.
So whenever like the 1, it's like, so whenever it's like 1, it's always gonna be 0?
Yes. Doesn't matter what the base is. Log, oops,
Okay.
log to any number, 4, 1 equals 0. I mean, because think about that. Anything to the 0 power equals 1. So when that's 1, answer 0.
Shows you go.
Okay. The next 3 are the 3 we want to focus in on. Those 2 are just sort of kind of freebies. Ones you just have to recognize. Number 3, we're actually going to put a name to it. It's called the product rule.
Wait, this one was the 0 rule?
For obvious reasons, yeah. Because anything with a 1 equals 0.
What was the first rule?
Identity. Product rule. This one is an important one. The other ones are just sort of, I see them, you recognize them. Product rule is one we have to work with. So if I have the logarithm, by the way, if I don't put a base to it, what do we assume? Who said 10? Yeah, it's base 10. It's called common log, so it's just a base of 10. If I don't put anything, so I'm not going to write in a log of a base every single time. So log of x times y. Hence, that's the reason why we call it the product law of the product rule, because I'm taking an x times a y, or 2 numbers times each other, or 2 expressions times each other. Then what I'm allowed to do is to expand that, and I can make it the log of x plus the log of y. And I can go either direction. Okay. Bring them back together into 1, condense it, or I can expand it into 2 separate ones. Depending upon what we need to do. So an example. The log of 4b. Well, that would simply break into the log of 4 plus the log of, you simply break apart the product into 2 separate ones. This can get a little bit more complicated. How about this one? Log of x times x plus 1.
So the rule is just that we can just add them together separately.
You can split the product apart. Take the x and the x plus 1 and split them apart. And have log of x plus the log of x plus 1. Now, where we're going to use that mostly is we're going to bring it back together. The better application of this is you're going to be given something like the log of 7 plus the log of x plus 1. Okay? Because you're adding two logarithms together, you can just multiply their arguments, just bring them back together. So you'd have the log of 7 times x plus 1.
But you can only combine it if it has the same bottom thing.
Same base, correct. Or we're better, log of 7x plus 7. Actually multiply them together. Okay. Yeah, and that's an important part. The fact that they have the same base, I kind of assumed that. Okay. If they have different bases, you can't put them together.
This is x plus 1, right?
Yeah. Is that better? So the product rule. As we start solving problems, you'll see this is very advantageous back and forth, however you need to put it. How many of you have seen that one before? A few? So those in my class last year probably did this. Okay, number 4. So what I suppose is the name of the next one. We just had the product rule, so now we're going to have the quotient rule. And with the product rule, we said multiplying, we add them. Now it's going to be divide, we subtract them. It's the same thing. Log of x divided by y is log of x minus the log of y. Let's connect this real quick. Do you remember if I have x to the negative second, how did I change that? Put in the denominator, right? 1 over x positive squared, right? So negative, moved it to the denominator. If it's negative, it's in the denominator. So if it's the denominator, you put a minus sign in front of it.
Wait, huh?
Denominator, we made a negative sign in front of it, minus. It's tied directly to the negative rule of exponents. So let's reverse it. If I had the log of 7 minus the log of 2, what would that be equal to?
Wait, so the
Logs.
What, you have a question?
so the order does matter since you have.
Absolutely.
Absolutely.
Whatever the negative sign is in front of, that number goes to the denominator.
So log 7 over 2.
So yeah, order does matter. And we could actually write them in a different order, okay? After you get this one done, let's give an example of one. You good? Okay, so let's say I give you negative, oops. See, that wasn't me. You saw that, right? Okay, so let's say we tell you the negative log of 4 plus the log of x plus 2. When I combine it, which one goes to the numerator?
The first one.
Goes to the numerator,
Oh, the second one.
X plus 2.
because it has plus in front of it. And then the 4 would go to the denominator because it's negative. So it really doesn't have to do what order they're in, it's what sign's in front of it. What sign is in front of it. Okay, yes. So what if there's negative on both? Both go to negative.
And then the numerator's what?
If I had negative log of 4.
And then if
minus
it's negative, it's
log
gonna be the opposite,
of
right?
x plus 2, that's gonna be 1 over, oops, 4. The logarithm of 1 over 4 times x plus 2. You just put a 1 in there. Yes, dear.
And then it would be the opposite if it's negative, right? It goes to positive when it goes to the denominator. And that says -4, and then in the last one, it's not negative, it's positive.
That's a positive 4.
I know, but it has the negative by it.
Negative in front, it's a negative log, it's not negative 4.
I know, does the
Remember-
negative log, does that have, do we change that at all?
This number here, what's the requirements on that? That number can never be negative, ever. Remember, it has to be greater than 0. So that 4, that value there will never be a negative number.
Wait, it has to be greater than 0, so no decimals?
Correct. No, it has to be greater than 0. No negative values. No negative values.
I do that.
So understand, there's a difference between a negative log and a negative 4. That's a negative logarithm. Okay? The argument cannot be. All right, you try this one. And then we're going to do probably the most important
Can you go back for like 1 second, please?
one more time.
No, like the bottom.
One more
Okay.
time. You good?
Yeah.
All right. So you try this one. I want you to expand this one. The logarithm of 3 divided by 4 times x plus 1. Expand.
Oh, no. This is like the reaction, that's the whole dozen of I didn't even, like, you know, Uncle Shirley, she's very, and she cares for her, not people pass, she very does not people that like her.
Don't forget that I am recording this. I'm not saying anything. I just heard the teacher's name, so I just want to make sure you know. This is being recorded. Hi.
It wasn't something bad. I love this episode. Let me teach you.
I did too. Well, that way. She's a great coach.
Cause we did this, like, we did expansion, but it was on adults math instead of a paper test, cause it was the end of the school year. It was gonna take a lot of people's grades, so it was easy.
What is it?
Well, we're going to be taking this and solving problems. Are you done? Do you need more time?
Sure.
Do you need more time?
No.
You good?
Yeah.
You will give me a final word, so I was gonna make sure. All right, here we go. Log. We're going to have 3 of them.
Wait, what was this, roll call?
Quotient. So log 3, because it's positive, so it's positive log 3.
Okay.
4 is in the bottom, so minus log 4. X plus 1 is also in the bottom, so minus log of x plus 1. And there's your answer. You got it?
I just combined the bottom.
So 4x plus 4. Okay, honestly, that's not wrong. Log of 3 minus the log 4x plus 4, that actually is acceptable. Yes.
Okay.
Wait, 4x plus 4? This what you put?
That's definitely the
Yes.
shorter.
No, you didn't, you put 4x plus
Race
1.
teacher trying to write that, but I was.
4x plus 1.
And we'll tell you though, on a test,
Combine it.
I'm looking for this one.
Oh,
Because they're being multiplied, I want to see them separated.
yeah.
Okay.
That is for now. All right, other questions? Yes?
So the x plus 1 is always going to stay the previous.
Okay, that's a very good question. In this case, yes. Because, hey, can you guys stop? No PDA. Okay, so, Monty asked a really good question. He said, if we have log of, let's just say x plus 1, is that x plus 1 going to be in parentheses? It has to be, because this is not the same as the log of x plus 1. This one, if you put this in your calculator, it would read the logarithm of x, take that answer, and then add 1 to it. We want to take x plus 1 and the logarithm of that. So if it's an expression, you definitely want to leave it in parentheses, absolutely.
Okay.
That's important. All right, very good. Last rule, number 5. We've had the product and the quotient. Now we're going to have the power rule. Probably the most useful rule of logarithms we have. Sorry? Probably. You're going to see a direct correlation from what I started with. Why do we need this to the power rule? Okay. So let's say we have something like, let's start off with the logarithm, and let's say we have x squared. You know what? Better yet, let's turn those around. Let's say we have 2 to the x. 2 to the x power. And I have that exponent is the unknown. The independent variable is my exponent. So what the power rule allows me to do is I can rewrite this by taking this exponent and bringing it out front. So I can write it as x times the log of 2. And I've removed the exponent from, I've removed the variable from the exponent. I've removed that independent variable out of the exponent, and now I can solve whatever I had to solve. And it really is, don't make it any more difficult, you're simply taking the exponent and put it out front. So if I give you like log of 7 squared, well, we know that is going to be the log of 49. What can I do with the 2? It's the same as 2 times the log of 7. Simply replace it to the front.
No.
Oh, what?
You don't have to put in parentheses, like you do the 2.
Here?
No.
The 7.
Not really. If there's one number, not really. I mean, I could have done that. But since it's not an expression, it's just 7.
You can though if you want, right?
Yeah, you can. I like parentheses, but I don't. Yeah.
So for this one, we're just putting the exponent in the front.
That's it.
For the, even if it's not a variable, it can be a number, we can still put in.
Correct. Okay, you ready for one to try on your own? Yes, you have no questions?
What if it's like x plus 1?
I'm sorry?
What if can the variable be x plus 1?
Wow, good question. What if I have log of 2 to the x plus 1? Is what you're asking, correct?
X plus 1 log 2? Question?
You bring the x plus 1 up front? Times the log of 2. Exactly right. Just bring it up front. Very good question. We're out here at 10:30, right?
Yup.
Perfectly on time. Let me give you one example to try, and then we'll be done.
Keep that up, bro.
Yep. I'll put in blue the problem I want you to try. I want you to expand. Expand this particular problem. Log of, oh, this should be good. Let's try, let's try,
I wanna get a line of.
I think he's hiding it on purpose.
I want to write it neat enough so you guys don't have to ask me 16 times. What does that say?
Shows in your ball thing. You don't have to do this. Then it's supposed to run on the phone. That's just like.
Expand. Bam.
Oh, I need sweat.
Okay.
Oh.
That's a lot.
This is really scary.
Marty, are you good at the top?
Yeah.
I'm gonna slide.
What is that doing? I get under the bed.
Power quotient.
Yeah,
product.
what it, oh.
What?
Yeah.
Really?
This is where,
Did I distract you?
No.
so about that,